start with your claim. Make it a little bit bigger. This is my claim. Whatever this thing says, write it down. Now, if it has no equal sign, it's an HA. If it doesn't have an equal sign, then we consider this an alternate hypothesis. Anything with an equal sign, whether it's the one you complement or the original one, is a null. That's your HO. This is a null. This is an alternate. Now we're going to learn today that we make the tail based on, and I want you to write this down, the HA. So I'm looking at this guy right here, and it's pointing to the left. So my tail test is going to be a left tail test. So I'm incorporating this right into the ones that you just did. Okay? And again, we use the symbols for population parameters because we're making this test on a population using our sample information. So number 27 says the standard deviation of the base price of a certain type of all-terrain vehicle is no more than, again, find a parameter you're using. Here's your claim. Write it out. How do you say no more than? Less than or equal to. This is the claim. So we determined it has an equal sign. Therefore, this is the note. So, HA is its complement. Everything but that. So if it's less than or equal to, the complement is greater than. If it's just less than, the complement is greater than or equal to. So this test, what type of a test are we going to do for this? Where's your arrow pointing? To the right. We're going to do a right tail test. So when we test this, we're going to do this. We're going to shade like this. Okay. This is a good time to throw the test part in there rather than just reading it out of the book. An amusement park claims, here's this claim, that the mean daily attendance at a park is at least 20,000 people. So you write your claim first. The mean is at least greater than or equal to 20,000. Since it has an equal sign, that's the HO. The HA, its complement, less than 20,000. So what tail test is this? A left tail test. It follows the HA. A company claims that its brands of paint have a mean drying time less than 45 minutes. So mean less than 45. This is the claim. Notice the claim could be the HO or the HA. Claim, we find the claim first. Is this HA or HO? HA, no equal sign. What tail test is this? Oh, where's the arrow pointing? Left. The left tail test. Whichever way that arrow is pointing, there's your test. Okay? Now, again, watch who makes these claims. An amusement park claims that the mean daily attendance is at least 20,000 people. Wouldn't they want a lot of people there? So wouldn't they want to say, well, it's at least, it's greater than or equal to 20,000. If I'm going there, or I'm a park, check on the parks or whatever I do, I might want to say, I think they have less than 20,000 people there per day, depending on who's saying this. A company claims that its plants have a drying time less than 45 minutes. Would they want to say greater than 45 minutes for their paint drying time? No. Yeah.
I have a question. It's kind of like but I was like wondering, like people that build parks for like the community, if they get a profit from that, like people going to the park, because it's pretty low park, so if they get a profit.
Yeah, I don't know. It depends what organization probably makes it like if it's a nonprofit or if it's built by the city or the town. I would imagine that it's all different, which is why a lot of parks don't sustain. They don't get enough, benefactors and donations and yeah.
Oh,
Yeah, I really don't know that information, but
I was wondering that too.
good. So, do you see where these claims are coming from? This guy is not going to claim that his drying time is greater than or equal to 45 minutes. Would you buy his paint? No. I would, if it's less than 45 minutes, yeah. So I buy his paint, and my paint takes an hour and a half to dry. So now I have to challenge this. I challenge his statement. I don't agree with it. So which is what we're looking at. So we're looking at also who's making this claim. According to a recent survey, 39% of college students own a credit card. So you got to play with the words a little bit here. Owns is the same as is has one, have one, or whatever. So here's your claim. This has an equal sign. This is an HO. The opposite is not equal. Because we're a not equal, the tailed is a two-tailed test. And we're going to see that in a minute. But just so that you know, the not equal will have a two-tailed test. So our goal is to set up a claim. If it's got an equal sign, it's the null, the HO. If it doesn't have an equal sign, it's the HA. Regardless of what it is, we take its complement. And we test always off the HA. We test off the HA. Good so far? HO can be false. But sometimes you make a wrong decision. We look at all the information and we still make the wrong decision. So there's errors that occur. So we test HO regardless if it's the claim. If it is true and we did not reject it, we agreed with it, we took it as being true, we made a good decision. If it is true, however, and we didn't take it as being true, we didn't reject it, we made a type 1 error. This is the error that we are going to watch and look at. This is the error we're going to be concerned about. So it was true, but we rejected it. And say I test HO, and HO is really false. It was really a false statement, but we didn't reject it. We made a type 2 error. This course doesn't address type 2 errors. We just address type 1 errors, but that's another type of error. If it was false and we rejected it, we did the right thing. So there's certain errors that we look at for this when we do these things for type 1 and type 2. And again, really it's a whole course in itself trying to decide which one is worse. And it kind of, they all depend on your scenarios. Like I have a few that I wrote out that hopefully will explain it a little bit better. So in a courtroom, I don't think you have this in your notes, do you? No. So in a courtroom, here are your potential choices and the errors that could happen. The choice 1, we cannot rule out that the defendant is innocent. So he or she is set free without penalty. Potential error. A criminal has been freed by accident. We should have processed him, but we didn't. Reasonable doubt, not enough information, whatever, we let him go. Okay, choice 2. We believe there is enough evidence to conclude that the defendant's guilty. Possible error. Well, the defendant was really innocent, and we convicted and put him in jail. So there's two kinds of errors that can look here. And what you want to make certain of is which one is the potentially worse error. If your person was innocent and we've showed he was not guilty, we made the correct decision, right? Innocent, we said not guilty, he goes home scot-free. Everything's good. The person was innocent, but we rejected that decision. We didn't find him innocent, we found him guilty. So we just put an innocent person in jail. Type 1 error. Now my person was really guilty. We didn't find him guilty. We found him not guilty. So we let this person go out on the streets. He really did this crime, but we didn't find him guilty. We released him. Type 2 error. He was guilty. We found him guilty. All is good. We were correct. So which one do you think is worse? Putting an innocent person in jail or letting a person who did the crime go free?
Innocent person in jail.
Innocent person in jail. What if this guy is a serial crime person?
Well, he'll get caught. He'll get him on the next murder.
What if this guy is just a common theft?
Either way, it's still wrong.
Yeah. Yeah.
They're both equally bad.
They're both wrong choices. They're both errors that we made.
If there's a theft that's released, yeah, that's bad because you get convicted. But if it's a murderer that's released, then someone's gonna get killed.
Yeah. So again, we have to look at the situation. Well, usually the guilty one will come around again and kill, but then another person gets killed. So guys, just let's go through this just for a little bit. So actually, it depends on, like Sheila said too, type crime. Is it bad that I let out a murderer versus letting out somebody that just maybe keeps stealing? No, both of them are wrong, but one is more dangerous to the public than the other. Is it bad to put an innocent person in jail? I mean, you can always, what do you call that? You know, like when they appeal. They can always appeal, right? So, what I'm trying to tell you is, these things will change based on the situation. So, we don't really get hung up with that, but I can tell you, it's your opinion. A lot of it is your opinion. But there are a couple of good ones in here. Where's I like this one. Let's work this one through. The USDA limit for salmonella contamination for chicken is 20%. So here's my claim. 20%. A meat inspector reports that the chicken produced by a company exceeded the USDA limit. You perform a hypothesis test to determine if the meat inspector's claim is true. Okay, when will a type 1 and when will a type 2 error occur? Now, this is the dangerous part. Say, I don't know if I have this out. Okay. I don't think it's going to fit on here. If you take a look at, in case you can't, I'm going to have to get rid of the words, but in case you can't see it, it's example 2 on page 352. So this guy comes in and he makes this claim. He thinks that he exceeded the limit. So how do I say exceeds 20%? The meat inspector claims it is equal to 20%. This guy comes in and he says, I don't agree. He claims that it is exceeding it. So how do I say that? Greater than 20%. This is the claim that we're going to follow. Is this an HO or an HA? HA. I had to get rid of some of those just so I could keep the chart up here, down here. So less than or equal to 0.20. Now, here's the problem. This is the guy that I'm testing. Okay, the people making the chicken, it has to be 20%. The inspector says it's more than 20%. So now, here's the problem. I'm testing that it's less than or equal to 20%. This is my HO. This is what I'm testing. I test this, and I find that this is true. It is actually less than or equal to 20%. The meat inspector is good right now. The place that's doing the chicken is good right now. So I did not reject the HO. I left it as that was good. I made a good decision. This was true, but I rejected this. It really was. He really had it less than 20%, but I rejected it. I really said he had it greater than 20%. What happens? What does that error cause? Not someone. It was really less than. It was really less than 20%, but I didn't reject it. I said it's not less than 20%. I said it's greater than 20%. So what happens? It's really less than 20% though.
It doesn't get put on the market.
Well, it does get put on the market. Or I reject it, so it's not going to get put on the market. So what's going to happen to this guy's business? His business is going to fail. He's got a bad reputation. You're going to buy his chicken? No, because you're thinking that it's greater than 20%, but in fact, it really wasn't greater than 20%. So didn't we make an error? We could harm this guy's business. Now, watch the flip side of this. I test this. It says it's less than 20%, but that's not true. It's not really less than 20%. The test came out false, so it's not really less than 20%. But I did not reject this. So it's not really less than 20%. It's really more than that, but I didn't reject it. So I made another error. Now what happens? People can get sick because now I approved this guy. He still keeps his business going, but he's got more than a legal limit for contaminated chicken. So what's worse? Hurting this guy's business or making more people sick? And salmonella could even cause deaths. Making people sick is probably the worst of the two. You know, the guy is unfortunate that we ruined his business, or we closed his business down for a little while, or we do something to help him get his limit back together. But would that be worse than people getting sick and dying from salmonella contamination? Even 20% is fairly high. It's fairly high. But what I'm just trying to show you is there's two types of errors that can happen. We only deal with the one in this one. We say if HO is true and we rejected it, we are looking at type 1 errors. And I'm not going to get you hung up on which is an error, which is not. But here's another good one. I like these. And again, I don't know if I'm going to fit this in. Okay. Yeah. A company specializing in parachute assemblies states that its main parachute failure is no more than 1%. How do I write that as a statement? Less than or equal to 1%. This is his claim. Is this his HO or HA? HO, because it's got an equal sign. This is the guy that I'm testing. Now, you perform a hypothesis test to see if this is true or false. And you have to determine which is more serious. Watch what happens. This is my claim. I'm testing this. It's really true. It really is less than 1%. Really is less than 1%. I did not reject it. It really was. I made a good decision. I didn't reject it. Great decision. It really was less than 1%, but I rejected this. I said it was really more than 1%. So again, who's it harming? The business, right? The business. Would you want to go somewhere where you think it's more than 1% of a failure rate? No. Now, here's the flip side. This was really false. It was really greater than 0.1%. And I did not reject that. I took it as it is less than 1%, but it wasn't. So now there's more parachutes out there that might not open. So who's that hurting? People in the parachutes, right? The people that are jumping. So which error would be worse? Type 2. So maybe type 1, I'm hurting his business a little bit, but you know what? I'll pick it up. I'm worried more about the lives that I might let go instead of the business. So again, it's just a kind of like, yeah, it's just kind of which one is worse at the time. All right, but we're not going to dwell on that, other than the fact that we use type 1 errors. All right, let's see if we can just get through the rest of this, guys. Come on, I'm having to talk over your voices. The level of significance. To decrease the probability that you will reject something that is true, you can lower your level of significance. Now, this is what happens. If I have a level of significance of 0.95, my error is 1 minus this, 0.05. Okay? If I have a level of significance is 0.80, okay, I'm going to get a 0.20 error of significance here. So we're going to leave out type 2 again. We're only going to talk about your type 1 errors, and we're going to write them like this. Generally, we use these. 0.1, 0.05. You're going to see these values used. Yeah, here they're listed. We pretty much keep to the same level of significance. Since your level of significance is the maximum allowable probability, one way to decide to reject the null hypothesis is to determine whether the probability of testing that test statistic, no matter what it is less than the level of significance. I want it to be less than that. I don't want it to be greater than that. Now, we call these things p-values. And you might ever have read an article and they usually just say p-val. They call it a p-val. Your p-val is the same as your area under the curve. And, well, the bad part about just describing this right now is you have no way to really test anything until we get to 7.2. So I'm just kind of going through formalities and telling you what we'll expect. But this is the same as your area under the curve, which is why we do a left tail test, a right tail test, a double test. So your p-val, again, we're not going to do it yet, but it's going to depend on which way you're testing. Your test always follows the HA. So when I look at this, I look at my HA. This arrow is pointing left. I have the left tail test. I kind of incorporated that into what you were just doing because it kind of makes more sense when you're looking at the claim rather than when you're just looking at letters. Again, we're going to be doing this real soon, and it will make more sense. Your greater than is your right tail test, and your two tail test is your not equal to. So just to know that that's coming. This is important, and again, you won't see it until we do this. The smaller the p-value of the test, the more evidence there is to reject the null hypothesis. So if we set a limit at 0.05 or 0.10 or 0.01, and your value under your curve comes out to be less than that, we're going to have to reject your null. We only test the null hypothesis. We always test your null. So we can't really test your p-values yet. They just can have you set the symbols up and then tell if it's a right tail or a left tail test. And we kind of just looked at that. So I'm not too hung up on this part. But we'll try one. We'll do one or two. A school publicizes that the proportion, make sure you get the right parameters for your population, of its students who are involved in at least one extracurricular activity is 61%. What's my claim? Is it the HO or the HA? HO. And what's my HA? So what's my tail test? Two tail test. Again, we can't test yet because we didn't give you the rest of the information to use. We just can kind of tell you what's coming. A car dealership announces that the mean time for an oil change is less than 15 minutes. So this is my claim. Mean is less than Would he want to tell you that it's less than or equal to? What's the advantage of him saying less than? Hmm? Well, you'd want to go there, right? If it's less than 15 minutes, if it's equal to 15 minutes, you're like, still 15 minutes and under. But isn't it a better advantage? He says less than 15 minutes. Isn't it like the same thing when they say less than $1 and it's 99 cents? You know, they always tell you that it's less than $20 and it's 19.99. But it's like a gimmick when you advertise. You never really made it up to that next number. So, of course he wants to say less than 15 minutes. Would you go if he said greater than or equal to 15 minutes? No, you'd find somebody that takes a little less time. So this is his claim. This is his HA. So what tail test do we do? Follow that arrow. Left. A left tail test. It's going to follow this arrow. Okay. A company advertises that the mean life of its furnaces is no more than. How do I say no more than? Oh, it's more than. Good. Greater than 8, because it'd be horrible if they advertised that it was no more than 18 years, right? So, of course I want to tell you that their furnace lasts more than 18 years. If I messed up and said no more than, they would say less than or equal to, and that's not a good way to advertise. So, is this my claim? Yes. Is it my HO or my HA? What tail test am I? Right tail test. Okay. Since we have no other way of we're not testing them yet. The next unit will be testing them. Now, this is important, and this is one of those things I gave you on your notes, and I'll put a chart up because this is when you test this. This is how you decide. You always test your HO, your no. So, when you test your HO, there's two things that can happen. You say reject the no, fail to reject the no. Okay, this is your HO. Only two things. You reject it or you don't. In which case we say you failed to reject it. So when you test with your p-value, and we're going to learn where p-value comes from, for your level of significance, where your errors are, if it's less than the allowable, if it's less than 0.01, less than 0.10, whatever one allowable error we have, you're going to reject your HO. You always want to test and assume that the HO is the right one. If it's greater than, then we're going to fail to reject the HO. And again, as soon as we start doing these, that's why this unit is a little hard to go through, because we're not really doing anything. We're just kind of giving you a lot of notes. And then we're going to be using them soon. There's your p-val test again. With your chart, this I'll give you. I'll give you a p-val test chart. And I'll give you these charts as when we start to do these. Also, what you want to look at before you close up is just you want to remember who's making that claim and how you want to set that up. If the claim is coming from a manufacturer, they want to look good. So, like if I say my tires give you 40,000 miles, how should I word it as a tire manufacturer? I'm going to say the average life of my tires, I don't want to say is 40,000. What is better for me to say? Not the tire manufacturer. Greater than or equal to 40,000 miles. I got to throw that greater than in there. If I'm the person who's challenging it, I think it's a less than. I don't even think it's equal to. So it depends who's making these statements. Tomorrow we'll actually start doing this work, which will finally make it a little more.